Hello. Today we're going to begin talking about Objective-C. This section will be in several parts, and this part deals specifically with the C language. So if you need a refresher course in C, this is part one of that. We're going to talk about scalar data types, what that means and what they are in C, variables and pointers, arrays of variables, structures, and we'll have a short demo showing several of these features. We call scalar data types scalar because there's a greater than or less than relationship between values. Even characters have a greater than or less than relationship in C. A character in C is actually a very small integer. It's an integer in a 1-byte range between 0 and 255 if it's unsigned, or between -128 and +127 if it's signed. So a lot of times we'll see characters and integers we'll see characters being used as integers, as very small integers in C. That's a very idiomatic feature of C. But the basic types, these scalar data types, are character, which is in C is in the blue, C-H-A-R or char. It is a 1-byte value. Integer is a 4-byte value, int. Long, we can also say long int if we want, is an 8-byte value. Float is a 4-byte value. That's a floating point value. Double is an 8-byte value. It is a double precision floating point value. And then long double is a 16-byte value. And of course, a long double can represent an extremely large number. These byte widths that I have listed here are the byte widths in as defined by Apple in iOS for Objective-C. Variables have to be declared in C before being used. Unlike some languages, I believe Python, certainly BASIC, some languages allow you to use a variable. PHP is that way. You can use a variable, you don't have to declare it before it's used. But in C, you do have to declare a variable before you can use it. And you have to declare it with a type. So you will use int, character, char, float, or some other type to declare your variables. Variable names can be of an arbitrary length, but they can only contain alphanumeric or underscore characters, and they cannot start with a digit. So the syntax is first the type, then the name, and then a semicolon. You can also use a syntax, you can also give a variable a value when you define it, when you declare it. You could say type, then name, then equals, and whatever value you want to assign to that as well. So some examples, and I challenge you to figure out which one of these examples is incorrect. If you chose the third example, you're right. We can declare multiple variables, as in the second example, on the same line, as long as they're all of the same type. The second two variables just simply begin with an underscore, but we cannot declare a variable that begins with a digit. Pointers. Don't get hung up with the idea of a pointer. A pointer is simply a variable that holds an address. That address is going to be an integer. But the pointers are typed. So we have to declare a pointer, and we use this star notation to declare a pointer to a specific type of data. So I have a simple example here. In the first line, we are declaring a pointer, and it is a pointer to an int. In the second line, we declare an int. We declare an int that's going to hold a number. And then in the third line, we actually put a value into that integer, 42. And then in the fourth line, we assign the address of my number into the pointer. The address is obtained with the ampersand operator. And this gets us a reference, or the address, of the variable that contains the data 42. And then in the fifth line, we're using the C printf function to print out my number, and then we'll print the value of my number is at address, and then we'll print the address of the number. As a reading example, I asked you at the end to take a look at printf and these format strings, characters, and see how we interpolate these things into this. If this is an unfamiliar notation to you, a review of C and printf and scanf functions would be in order. The pointers are not overly tricky. They're not terrifyingly dangerous. They are very useful, and in Objective-C, we make large use of pointers in everyday operations. An array is a series of values, all of a single type. We declare an array just like we declare a variable. We declare it with an index range, and that index range is declared, or actually it's not a range, it is a number of objects in the array. And that's placed as an integer in between square brackets after the variable name. So the first index of any array is 0. So in this rates example, I have an array of floating point numbers called rates, which has 10 values. The first index will be 0, the last index will be 9. If you are used to 1-based arrays, get used to 0-based arrays. Again, there is in Objective-C, being a strict superset of the C language, the first index of an array class is 0. One very important point, especially when working with C, is that the name of an array without an index is a pointer to the first address in the array. So if we just said float, if we just said rates in this example without indicating an index, it would be a pointer to that first index in the array. A structure is like an array, except the types of the values inside a structure can be different. So I have a short example here. This declares one structure variable called point. We don't usually do it this way, and I'm going to come back to that in a minute. But we have a point, and it has two integer values inside the structure point, an x coordinate and a y coordinate, and it also has a floating point value, color. And we can, rather than indexing into a structure using array notation like we do with an array, we index into a structure using dot notation. And dot notation becomes extremely important in Objective-C as we move forward. It is used for something else, but because dot notation is also used for structures in C, it is a very easy syntax to remember in Objective-C, because it allows us not only to do what it refers to in Objective-C, which we'll get to in the next couple of sessions, but it also allows a seamless integration with some of the structures that are used, the flat C structures that are used in Objective-C. I know that doesn't make any sense right now, but it will. But we use dot notation to get into the variables inside a structure. So we have point dot x coordinate, and we're assigning it the value of 50. A point dot y coordinate is assigned 30, and point dot color is assigned 0.35, whatever that means. And I forgot the semicolon if you're paying attention. And then on this line, there should be a semicolon right here. And I'll just go ahead and fix that. And then, again, we're printing out with a format that the point at x coordinate, y coordinate with color, and then the color of that point. As I said before, I sort of mentioned before, structs are usually declared using typedef, and when we do the demo, you'll see an example of that. So on to the demo. What we have is a simple console mode program that calculates the distance between two named points. And we're going to allow the user to name their 2 points of interest, and then enter the x and y coordinates of those points. And then we're going to input that data using a C function called scanf, and that stands for scan formatted input. We'll calculate the distance between those 2 points using the Pythagorean theorem, and then we'll output the distance using printf. And we've already met printf briefly. Printf and scanf are an input-output pair. Scanf for input and printf for output. So let's go ahead and look at that demo. I've already set it up. And what we have is a console mode program, and we'll be showing you how to create one of these. But it is a I'll just go ahead and do that now. If we go to File, New Project, we see our friend, the project window, and we go to Application and select Command Line Tool, and that's how we create one of these. At any rate, here we see a structure being defined, and it's essentially the same as the structure we looked at before. Instead of using color, we're using a character array, an array of 20 characters, and that array is called name. And we also have an x-coordinate and y-coordinate declared as integers. It's perfectly okay to declare multiple values multiple variables on one line, as long as the type is all the same, and here it's all integer. But the difference with this structure, point, is that we're making it a type. So it's just as much now with this keyword typedef. It's just as much a point. Point is just as much a type now in our program as float or int or char or what have you. So we can use this typedef struct and then the internal variables and then point. We can use this value point now to declare 2 instances of point. We're calling them point 1 and point 2. And then we're also going to need a variable to hold the distance. And I want that to be a float because it's going to be a decimal value. It's going to have a decimal part. So these 12 lines, and we see this pattern very often in C programming, first print prompts and then scan for input. Now, as I mentioned or may have mentioned before, scanf expects that you pass it the address of the value that you want to get in, not the value, just not just the name. And as I mentioned, this name without the index set is really a pointer. So we're scanning in a string point1.name. Now, when we scan in an integer, the x-coordinate of the first and second point, or the x-coordinate of the first point and the y-coordinate of the first point, when we scan that in, we need this address of operator to actually scan that in. So scanf expects a pointer. It expects an address of what you're scanning into, not the variable name. So this is why we discuss pointers, and this is why we talk about this address of operator. We do the same thing, again, getting the name and the x and y coordinate for point 2. The distance is calculated using the Pythagorean theorem. This is the very simple calculation, and I would encourage you to study it if you don't understand it. And then we output the information. \n is a new line character. The distance between the first name, .1 name, and the second name, .2 name, is a floating point number distance. And then we return. When we run this program, where is that input-output taking place? First, it's building the program. We have a successful build. The input and output happens in the console. And we'll broaden this up and take a look. And we'll call the first point here. And we'll say the x-coordinate of the first point is 31, and the y-coordinate is 7. Let's just plugging in numbers. And then the second point, we'll call it there. And the x-coordinate is -98, and the y-coordinate is 14. And they'll give us the distance there between here and there as 129.19. So that's it. I would encourage you to study this program, attempt to make some modifications, and we'll talk about those here in just a second. This program will be available to you. So for further reading, I would like for you to look at format specifiers for printf and scanf, the percent specifiers that we use to get values into printf and scanf format lines. Also read up on using the scanf function, understand why we use pointers to values and not just those values. And also, for reading ahead into our next session, look at user-defined functions in C, in the C programming language, how to make your own functions, and because we'll be doing that right at the beginning of our next session. I would also like for you to take a look at this program again, the one that we were just looking at, and try to calculate the slope between the 2 points in the program. When you're doing that, be sure to catch the case when the line is vertical. Calculating the slope involves putting some distance over another distance and dividing them out. If that denominator is 0, the line is vertical. That's a big hint to you. But be sure to catch the case when that line is vertical, and don't attempt to divide by 0. Okay, hope you can use this information, and I thank you very much for your attention.